Welcome to the talk Domain-Driven Transformation. Um, we might not have enough chairs, but here in the room, better too, there are more. So if you want to grab a chair, you can take them one there, but you're fine. Okay. Yeah, I would like to wake my clicker to wake up. Okay. I would like to say I know it's after the lunch break, and I hope you will not be too tired. And I'm going to start with a little story. When I was a little boy, my grandmother used to take me by the hand and take me down to the port. I grew up in Hamburg, in northern Germany, a big port city. And my grandmother, she showed me the big steamers rolling in and out of the port. And she also showed me the old warehouse where already her father, my great grandfather, had traded cocoa and coffee, basically 100 years ago. And when my great grandfather opened his window in his office, then he could smell the whole wide world, the roasting coffee, the ripening bananas, sometimes even wild animals. And back in the day, the ships were unloaded manually. So-called stagers, men had to literally go onto the ships and carry the goods on their backs from the ship and onto the ship again. And then the container was invented and times changed forever. Like later for us, the container was invented and times changed forever. Here the container was a steel box. And that meant the stagers, the people that were loading the ships, they had to change their jobs. Now they became crane drivers for the container cranes and container bridges. And also the old warehouses were not needed anymore. And what happened to these old warehouses? Well, you can see when you look closely, there's decay here. And there's graffiti there. So a big part of the port of the city of Hamburg was kind of abandoned. And eventually the Senate of the city said it cannot go on like this. This is a great area and it's near the water and we have to do something with these old buildings. So they had an idea and they made a plan. They said, well, let's take this old warehouse and build something new on top of it. Let's build a concert hall. And then they started and they, well, put out the core of the old warehouse, kept the walls, and then you see there's a long time a construction site, and here you can see the concert hall and the hotel that that were planned, growing and growing and growing, and of course it took 10 years longer than planned. It was 10 times more expensive, but eventually there was a big party. And the Elbphilharmonie, as it's called today, the concert hall, was opened, and now it stands there in the port of Hamburg. And again, the big wide world is coming to the concert hall, to the old warehouse again. You can see here the tourists from all over the world, singers and musicians from everywhere. Here's one more seat if somebody wants to sit. And what was done to this old warehouse? That's what we want to do with software also. We want to take something old and monolithic, like the warehouse. Keep the good parts, get rid of the bad parts, and let something new and beautiful grow out of the old software. That's what we want to do with legacy software here. And I'm going to tell you in the next 45 minutes how that is going to work. And who am I? My name is Henning Schwentner. I'm the guy with the many kids. So I have I have 3 boys and 3 girls. Yes, thank you. And wait for it, they have 3 different mothers. Yeah, there you see. So I know how to operate in complex situations. And that is important for what I do at work, where I work in complex situations, where I work as a coder coach consultant. So I work with teams on their big piece of code, typically old, typically monolithic legacy code that has to be modernized, modularized here. And that's always complex here. And coder coach consultant, when I'm lucky, I get my hands on the keyboard, but most of the time I'm doing what I'm doing with you. I stand in front of people telling them how to do it right with software development, or telling them what I think is right. And in theory, in exercises like here, and also in consulting, I work with teams on their big piece of software. And spoiler alert, in 45 minutes, of course, you will not learn how to do everything on your own. So consulting is typically a good idea here. Okay, I work for a company that's called WPS in Germany. And this transformation topic is so important for me that I just published a book about that. Domain-driven transformation is called Like the Talk. The English edition is not out yet, but there is a German edition. So if you do understand German, well, that might be possible. And my other book is Domain Storytelling. That's already out there. And storytelling, these are the German editions, and storytelling, I like to tell another story, this time not about a port, this time about a piece of software. So please imagine with me the Alphorn auto leasing company. And guess what they do, right? They're doing car leasing, auto leasing. What is that? Well, normally when you want to get rid of your old combustion engine car and you want to buy a new green zero emission car, then you give a big bag of money to a car manufacturer. And the car manufacturer gives you, the end customer, a car. If you don't have that big bag of money to buy this new car, like the emission-free car that we have on the outside here, then the leasing company comes in between. And the leasing company pays the price for the car to the car manufacturer. The car manufacturer gives the end customer the car, and the end customer makes a monthly payment, the so-called installment, to the leasing company. That's car leasing on a very coarse-grained level. And I think we can all well imagine that Alphorn, the leasing company, has a big old legacy system in place, which is obviously called Monolith. So I'm a 6 times dad, so I'm allowed to pull dad jokes here. And Monolith was built around the change of the millennia with the technology that was en vogue back then. So that means Monolith is about 20, 25 years old. And maybe you've seen the talk of Simon Brown just before lunch where he was talking about the C4 model. This is a C4 model context diagram where we can see the context of Monolith, the system, which is used by the salespeople and the risk manager inside of Alphorn. So we have the customers, and the customers, they interact with the salespeople. So the customer closes a leasing contract with a salesperson, and then the salesperson creates and calculates these contracts in Monolith, and the risk managers, they assess the risk in Monolith. So Monolith is an internal system not made for the customers. So Monolith is a bit like a beautiful ship, or a ship that was beautiful back in the day, and well, then the 25-year passed, and today it feels a bit like a wreck, and well, everybody hates it. The users because it's so slow and so ugly, the developers because, well, there's all this old technology and it's so big and everything is connected to everything else. So there are several problems with this old legacy system, and there are several problems with all the legacy systems there. What are typical issues? Well, it takes a long time until a change that is made to the system comes into the production. So we have a long time to market. The system is error prone. Even the smallest change that we're making to the system is likely to break anything. And that's one of the reasons why we have such a long time to market, because even the smallest change we have to test manually, and it takes a long time until we bring it to production. So that means the long time to market and the error proneness lead to, well, let's use the waterfall model, because then we have these long cycles. So we have a traditional approach here as well. Then when we're working with different teams on legacy systems, these teams get into each other's way. So there are no clear boundaries. The teams don't have their own area of the code where they can work without making problems for other people. And then it's hard to build new ideas into the system. The system is working okay for the old ideas from 20 years ago, but for today, well, it might be tough. Also, Legacy systems often come in groups, not only one legacy system, but other legacy systems as well. And sometimes they are doing more or less the same because our leasing company bought other leasing companies, competitors in the time, and they had their own IT system, which were doing more or less the same, but not the same enough, so we still have to keep these systems. Well, so it's not nice to work with legacy systems. That's why Alphorn's boss, the boss of the leasing company, says, well, we want to modernize that system. And I think they are doing an important thing here, that they say modernize it, not replace it. Why is that? Because, yeah, this old legacy system that treats like a wreck and everybody hates it, but this old legacy system has turned so old for a reason. And that reason is that there's a treasure hidden inside that rack. And that's the treasure of the domain knowledge. So the system has become so old for a reason, and that reason is that it supported the work of its users, the work of the domain experts for a long time. All the systems that didn't do their job well, they passed away in the 20 years. We don't have to worry about them. But this system that did its job in a good manner, that's what we have to worry about. And it's usually worth to dig out that treasure here, to get rid of all the dirt and all the dust that has piled upon the gold here and dig for the gold here. And this idea of modernizing the system instead of replacing the system, that means kind of a mind shift for many legacy systems because, of course, for many legacy systems we have this here. I hate this old mess. I don't want to work with this anymore. And usually it's a good idea to reframe yourself and focus on the good thing and see, well, this system has earned us money for decades. And let's focus on that part and save that for the future so it can make us money for the decades to come. That's what we want to do. Dig out the treasure. And modernizing usually also means modularizing. At least that's what the consultant tells them that they are hiring. Modernizing usually means modularizing. Why? Because old systems have this tendency to be big systems. They started as a small system 25 years ago, and then, well, it grew and grew and grew, or it grew. And now we have this big system, and there are no clear boundaries, there are no modules in the system, and it's a good idea to bring modularity into the system again. And how these modules are implemented are these modules inside of one deployment unit, a modular monolith, or do we even want to go the step to making microservices out of them? Well, that's another question. That's a question for later. The first important thing is it's a good idea to modularize this legacy thing, this big ball of mud. So we want to come from the monolith to modules. Maybe modules inside one deployment monolith. And when we have these modules, then we can answer these questions. Do we want to modernize or do we want to replace? We can answer this in a more detailed manner. So, for example, we see these parts here. That's something that we want to carve out of the old system, these modules, because that's good in the old system. Well, this part, that was always bad in the bad system. Let's build it new. This part, well, back in the day, we had to build this our own, but today there's a standard solution, maybe a software as a service we can use. So we buy this here. And buy is meant in a very broad sense here. Using an open source component is also buy in that sense. And, when we start to modularize and to modernize our system, our patient, then we first have to see, well, what are the diseases that it is suffering from? So the system is like a sick man, and we want to find out what are the diseases that it is suffering from, and different diseases require different treatments. What are typical diseases? Well, typical disease is that the system has become a big ball of mud. Big ball of mud means everything is connected to everything else. No clear boundaries. Sorry? It's like cancer. Yeah, that's true. The problem, one of the problems with big balls of mud is that they are even growing, and everything that was nice will also be torn into this big ball of mud. And another disease is the poorly expressed domain knowledge. So yes, there is domain knowledge in the system. We heard that the system did its job well for 20 years, but that domain knowledge, well, it's hard to find in the system. When we look at a certain line of code, we cannot say, is this business logic or is this technical logic? This is all mixed up. Also, we don't find the language of the domain in the software. It's hard to find that. So there is domain knowledge in that system, but it's poorly expressed. And then, third disease is the bad or the unfitting team organization. So maybe we have the one big monolithic team here, or we have layer teams, and well, this will not work out with the new, more modular idea that we have to fight the big ball of mud. So those are typical diseases, plus, of course, in real life, we typically have combinations of these diseases. And as the saying goes, the dog can have lice and fleas at the same time, and this is typically the case. So the good news is there are cures against all these diseases. There is what we call strategic transformation against the big ball of mud, and tactical transformation against the poorly expressed domain knowledge, and there's team organization and transformation to cure the unfitting teams here. And transformation, that's something big. We need smaller steps to fill this transformation with life, and for that there exist refactorings, so-called domain-driven refactorings. So when we are doing strategic transformation, there are strategic refactorings, still something big, which are supported by tactical refactorings against the big ball of mud. Smaller steps that we can take in one sprint, in one iteration. And there's socio-technical refactorings to reorganize the teams, and tactical refactorings against model anemia to get the domain knowledge out of this. We only have 45 minutes, so we can't go into too much detail here, but I can point you to the catalog of domain-driven refactorings that I'm collecting on my website here. Schwentner.io. Schwentner.io/domain-driven refactorings. And that's an open source catalog, so if you find new refactorings, please submit a pull request, and then the catalog will grow. I will focus on the strategic part today because I see that is the part that most teams I'm working with struggle the most. So strategic refactorings, that's this. We have the big ball of mud, we want to modularize that. So we have the big ball of mud, and we want to turn it into something more ordered, more vertical, into something thinner here. That's what we want to do. And strategic transformation is done in 4 simple steps. Well, of course, these steps aren't simple. And also, it's not that you're doing the 4 steps and then you're done. It's more like steps of an iteration that we have to do again and again. But still, it helps to have some structure here when we approach a strategic transformation. It starts with rediscovering the domain. So first we put the old system aside and understand our problem again. Then with that problem knowledge, we model the target architecture, our ideal architecture that we would want to build if we could start on the green field. Then we align the existing architecture with that great idea. And in step number 4, we move from here to there. Okay. That's the basic idea. Let's have a closer look at that. So the first step is the domain rediscovery. What do I mean with that? So it's important and maybe counterintuitive that usually it's a good idea to first, when you want to modernize an old piece of software, to put that old piece of software aside. So when we want to modernize a legacy system, we have to put aside that legacy system. When we want to split the monolith, we have to put aside that monolith. We have to put aside the solution that is already there and re-understand the problem that is behind that solution. So there's, in many of these old legacy systems, a bit like a Stockholm syndrome effect for both the users and the developers. The users, they are so used to using the system that they think my work is using Monolith. No, your work is not using Monolith. Your work is to sell leasing contracts. And Monolith is just a help, just a tool, just a solution to help you do that job. And we have to re-understand the problem. We understand the domain, and the domain as it is today, not as it was 20 years ago, to know what is the right software that we need for that solution. And that will help us modernize and modularize there. So that means for us developers, a mindset switch, we have to move on from only thinking about the technology, just thinking about the tooth wheels, to thinking about the business, thinking about the dollars. So it's a sad truth, I know, but we're not building the software for us. We're not building the software for technical beauty. We are building the software for them, for the users. And that means, well, to build software, we, the tech people, have to understand them, the business people. If we don't do that, we will not be able to build great software. That means, of course, we have to talk to them. So we have to get out of our basement, our dark and damp basement. Get into the architecture elevator, talk to real people here. Because what we want to have is a common understanding between tech people and business people. We want to understand what they are doing. And to get that common understanding, we also need a common language so we can talk to each other. So we want to learn the domain language, understand what a leasing contract is and how that is closed. And we even want to use that language everywhere, even in the code. That's the idea of that ubiquitous language here. Anybody here heard the word ubiquitous language? Many hands, great. That's a term from DDD, from domain-driven design, this idea of we want to understand the domain language and use the words from the domain language everywhere, ubiquitously, even in the code, especially in the code. And when we have this common language, this ubiquitous language, then it's easier for us to get rid of these telephone game effects. I don't know if that's a game played in your country. In German, it's called Stille Post. It's a child's game where one child whispers into the next child's ear a word, and then because they're whispering, they misunderstand each other, and then something funny comes out at the end. If children play that, it's funny. If we're doing that in software development, well, it might be funny at first, and then it soon starts to get very unfunny. But this is what's happening. The user says circle, and the requirements engineer understands square and tells that to the software architect. And the software architect understands triangle and tells that the developer. And then the developer, what are they supposed to do? Well, when we're lucky, if we're lucky, they are programming triangle, but that's still not what the user wanted, right? So what is better than playing the telephone game here is go into direct communication. And these roles that are in between here, business analysts, requirements analysts, requirements engineers, whatever you may call them, changing from being translators, as they are here. Oh. to be facilitators, enablers of communication here on the right side. That's what we want to do. And how do we achieve that? Well, there's a family of methods that can help us called collaborative modeling. The idea of we want to build the domain model together, us and them, the domain experts and the technologists. Methods you might have heard about are event storming and domain storytelling. Who has heard event storming? A few hands. Who has heard domain storytelling? Also some hands. Okay. So what we want to do here in our example at Alphorn is we invite the right people into the room. The right people in this case would be the users of our Alphorn system, a risk manager, a salesperson, also a customer probably, and then let them tell their story and get a common understanding of what it is that they are doing. So in our example, we will first hear from the customer that they tell their wish for a car to the salesperson. And then the salesperson tells us, well, the next thing I do is I calculate the installment for the contract. Installment, we ask, that's a strange word, what does that mean? And then they can explain us, well, the installment, that's a payment that the customer has to make monthly. Aha, monthly? Can it also be not monthly? Yeah, it can be also quarterly. Okay, so this is something that helps us spark a discussion about what's going on in the domain. Next thing is the customer signs the contract if they can afford the installment. And then the salesperson will pass on the contract to the risk manager, and the risk manager will then check the credit rating. Credit rating is the risk of the customer. The risk manager calculates the resale value. That's the risk of the car. And based on these two factors, the risk manager votes the contract. To vote means say, yes, we want to do this contract, or no, we don't want to do this contract. And let's assume they vote positively, then the salesperson gives the car to the customer. So what you can see here, that is a domain story. And here you can see why it's called domain storytelling. The idea is we let our domain experts tell their story, and while they are telling it, we repeat it in our own words or in our own diagram to show this is what I have understood. Did I get you right, dear domain expert? And then my domain expert can say, yes, you got me right, or no, here's a misunderstanding, we have to do this a bit different. If you want to know more about that, please read my book on the topic. And if you want to know even more about that, then consider coming to the Como Camp. That's the yearly unconference on all these collaborative modeling topics. Event storming, domain storytelling, but also user story mapping and so on. So now we have step number one. We have re-understood our problem. And when you remember the domain story, we didn't talk about computers at all. We only talked about leasing, and that's good. And what can we do with that? Well, we can determine the target architecture of our system with that. And we do that by drawing boundaries. We want to draw boundaries. And for that, we ask the question, which activities belong together from an actor's perspective? Okay, so what are actors? What are activities? Domain stories, they consist of three kinds of elements. The actors, like customer, salesperson, risk managers, the people that are doing something. The work objects, like car, contract, installment, the other icons. And then the third element are the arrows, the so-called activities, what the actors are doing with the work objects. Here, this is an activity, votes. That's an activity, calculates. This is an activity, gives to. And now, to find boundaries, we ask the question, which activities belong together? And we ask that our domain expert. That's something that we want to do together with our users, with our domain experts. And then we learn the steps 1, 2, 3, and 8, they belong together. And they form in this big domain of car leasing what's called a subdomain with the name sales. And we learn the steps 5, 6, and 7, they also belong together. and form another subdomain, which is called risk assessment. So subdomain, like ubiquitous language, a term from DDD, from domain-driven design. And so far, we didn't do any technical stuff, any programming stuff. This is all still happening in the business, in the domain. But we are using this for the technical stuff now. We extract from that domain story and from the other domain stories that we're usually going to do, we extract these subdomains and put them into another artifact, the so-called context map. And this context map, that is the target architecture on a broad level. So instead of Monolith, the one big thing, we will build now something like risk assessment, sales, and probably we will find other modules here as well. Didn't fit on the slide, that's why I only found two, but usually in one domain story and in several domain stories we will find more subdomains, more bounded context, another DDD word, context map it's called, because we have these bounded contexts. A bounded context is a module in the software, a domain-driven module in the software. We take a subdomain and build one module in the software for it. That's called a bounded context. Okay, so now we have an idea of this is the software architecture that we would build if we could start on a green field. But of course we aren't on a green field. And this is the point where we have to get the monolith out of the box again and see how does this fit together. So step number 3 is aligning the current architecture with the target architecture. And for that we first have to know the current architecture. So we have to analyze the source code together with the developer. Sometimes it makes sense to have an architecture analyst with us, and often this can be done tool-based. If you want to know more about it, I can recommend you my colleague's book, Sustainable Software Architecture. So in our case, where we have Monolith, we gather the developers and the architects and say, well, let's have a look inside. How is Monolith structured on the inside? And then we learn, well, on a containers level, again C4 model here, we can see, well, Monolith is built out of a front end, which uses a back end, which stores its data into a database. And we can also see the technology, well, JSP servlets, EJB2, at least it's not EJB1. Yeah. And we can also see something good here in this architecture. We can see the system has a layered architecture. Layered architecture means from the above we can access the below, but not the other way around. That's good. And if we go into more detail, component view, then we will see, well, the front end is made of a leasing servlet and a partner servlet. The back end, there's a calculator and a contract service. In the database, we have a table contracts and a table partners. Of course, written in all caps, because that's how God meant database tables to be named. Or maybe not. Okay. Again, there's something good to be seen. We talked about ubiquitous language earlier. There is a bit of ubiquitous language here. We're using domain words for the names. That's good. Partners, contracts, calculator, that are words from leasing, not words from tech. That's good. Also that we have this horizontal structure, this layers, that's good. What is not so good is that there's no vertical structuring at all. That's this big ball of mud thing, right? And these layers, they are huge. And so it's still pain here. And what do we do about that? Yeah, well, we want to come from the current to the target, and let's see how that fits together. Let's see how in this current architecture we can find the target architecture. And let's focus only on the backend because that's only complicated enough. So where do we find sales and risk assessment? That's our target architecture. Where can we find that inside of this? So for sales, we need these components: calculator, contract service, contract, and partner. We learned that from our domain storytelling. or collaborative modeling sessions. And for the risk assessment, we need the partner service and also the contract service and also the contract and also the partner. Okay, there are parts which are easy, the calculator and the partner service. Well, they belong only to sales or only to risk assessment. But then, of course, there's this big overlap in the middle. And welcome to the real world. That's, of course, what most parts of the system out there look like. What do we do about that? Huh? So, well, first idea is do something like that, right? Get this kind of decomposed. And how can we do that? Doesn't this mean, well, there's a lot of duplication going on here? Isn't this just copies, contract here, contract there, partner here, partner there? Well, we cannot answer that question. Is that really duplication on this granularity level? We have to dig deeper to understand that. We have to go onto a class level. We have to look into contract and see what that means. And here also into contract service. So let's see on a more fine-grained level, on contract service, on contract level, on a class level, on a method and field level, where we find these context boundaries. So when we look at the implementation of these classes, we see, well, there is the contract service, which has two methods, sign contract and vote contract. And we have this contract, well, which has a bunch of getters and setters. So get contract number, set signature date, get signature date, and so on. So what we're seeing here is a typical combination with a big ball of mud. It's an anemic domain model. Anemic domain model means the business logic and the business data, they are separate. There is no capsule around it. So where would we find sales and risk assessment here? You remember the domain story? There is this signing the contract part that is part of sales, but not voting the contract. And for that signing the contract, we need the contract number and the signature date, but not the credit rating and the voting result. And on the other hand, for the risk assessment, we need the logic for voting the contract. And for that, we need the contract number and the credit rating and the voting result, but not the signature date. So if we separate this, we see, well, there is not really much duplication. So the only duplication is here in the contract number, and that's no surprise because that's the identity of the contract. And we have to know in both parts of the system that we're talking about the same contract here. So what we're beginning to do is building two models for the same thing. One model for contract in the sales context, and another model for contract in the risk assessment context. That is this idea of strategic design of DDD. That's this idea of bounded context of subdomain. That we can have different models, smaller models of the same thing here. It's also the idea behind microservices in the end. Okay, how do we come to this architecture? Well, that will take some time, of course. And that's why it makes sense to collect the refactorings that have to be done in an improvement backlog. So we write down refactorings like we want to extract a bounded context sales, and we want to extract another bounded context risk assessment. And then we need tactical refactorings for that, extract a specialized model for contract, extract a specialized model for contract service, and maybe we even split these refactorings into smaller refactorings. Because in the end, what we want to have in the improvement backlog is something that is sprint ready. Steps that are small enough, refactorings that are small enough that they can be done in one sprint. And of course, here we want to do something similar. And then we come to step number 4, doing the move. And beside our product backlog with the user stories And the improvement backlog, we now get the improvement backlog with our improvements, with our refactorings. And when we're starting a sprint, now, when we're planning a sprint, we will not add only user stories to that, but we will also add improvements. We will also add refactorings here. So typically it's a good idea when starting with a transformation to be aware that it will take a long time and to reserve some of your velocity for the transformation here. Because that will not be done in 1 or 2 sprints. That will take months, or truth be told, it will take years until we're really done with the transformation. Of course, we will never be done. But don't tell your boss right from the beginning. Because what's going to happen is something like this. The sprint is done, and then we plan some new user stories and some new refactorings there, and then eventually, well, the improvement backlog is empty. No, of course not. In real life, there will be new improvements coming up here. The transformation is going on and on and on. And I know it's after lunch, and I know there's not a lot of oxygen in this room, but I still want to work a bit on this code here, so you get an impression that these big things, the big transformations, they are made from small steps, small viable steps, evolutionary steps. That's very important here. So when we want to carve out something out of Monolith, let's say we start with carving out the risk assessment part, then we have to see, well, we want to carve out vote contract. Vote contract, this method is called from somewhere in the code. Then we see vote contract calls some methods here in the contract class. And I said we want to move on with small, viable, evolutionary steps. So the first step that we're going to do is create an empty bounded context risk assessment. That's a namespace or a DLL or a microservice. And we deploy that into production. That works. And then we create an empty class contract service. That's also something that we could deploy to production. And then we copy the method vote contract here to that site. And then we get something like this, dependencies from the risk assessment bounded context to the monolith thing. The next thing is to say, well, let's replace the implementation of vote contract with a call of vote contract on this side. Then we get rid of these dependencies here. And now we can say everywhere where we're using the old vote contract, we can now use the new vote contract and replace that. Small steps again. We again are able to deploy this into production. That's important because there will be new features in between, new requirements in between that have to be put into the system. And maybe eventually we come here where nobody calls the old vote contract anymore and we can replace that, can delete it. And then we move on with the contract as well and go there in baby steps. I'm not going to tell you all these baby steps. The important point is we want to have these baby steps, these viable steps to be evolutionary. And here we're talking only about the domain model hard enough. We want to do something similar also with the data model, which is even tougher, but also possible. Okay. Eventually, we will get rid of the old stuff here, and then the monolith is going to shrink, which is good. And also here we are already in the new shiny world where we want to end up. So the next thing that would be done is tactical transformation. I already told you this is anemic, and what we extracted is still an anemic domain model. Unfortunately, we don't have the time to talk about that today. Also, we don't have much time to talk about the team organizational stuff. One idea that's important as a takeaway, one context belongs exclusively to one team. On the other hand, one team can have several bounded contexts, but we don't want to have bounded contexts that belong to several teams here. Okay. That was already a lot, I know. What else is there to say about this domain-driven transformation stuff? Well, the technical transformation with the anti-anemia refactorings, that's interesting to look into that. The socio-technical transformation, how do I transform my team or my teams that they can work with the modularity, the new. And technical transformation, often before we can start with a journey like here, we have to stabilize our patient. Before we make the operation, we have to stabilize our patient. So if there is no version control or no CI/CD pipeline, then that's something, not enough automatic testing with unit tests, then that's something that we want to start with to stabilize our patient to be able to make that operation. Okay, and with that I come to the conclusion. Of course, in a talk it often feels like in this old meme, how to draw an owl. Step number 1, draw 2 circles. And step number 2, draw the rest of the damn owl. I hope I gave you an idea of step 1A, 1B, 1C. And of course, it's tough to do it in real life. So if you want to know more, buy my other book when it is out there. And I want you to take at least one lesson with you. And that is monolith transformation is possible. It's possible in small steps. And it is hard. Make no mistake, it is hard, but it's still possible. And don't give up. Find the small steps that are there to transform your software. And one mistake that is commonly made is to go on the journey alone and make all the mistakes yourself. You don't have to do that. A better way is to take somebody with you on the journey who already made all these mistakes. And, and I could recommend you somebody. Just talk to me after the talk. And being in advertisement mode, I also want to advertise for something good. Please consider making a blood donation. They only need half a liter of your blood. And you don't have to look into your arm when they put the needle there. And I think there is something with blood is here in the exhibition, but unfortunately they don't take your donation, but probably there will be a blood donation store next to you. And with that, I say thank you. That's the end.